Hello YouTube, it's your boy again, Solomon.Koroma. Today I'm going to teach you guys out there, for those who want to learn PLC. Nobody's perfect, but at least with the small experience I have, I want to share with people that can reach me all over the world, that don't have the opportunity or don't have the money to study PLC, but they are working in industry. What I'm going to teach you guys is how to do analog scaling, basic analog scaling. This is purely basic plus HMI, because most people don't understand how these things work. They just say it, okay? Now what I'm going to do, we're going to use uh, a boiler, maybe measuring from 0 to 100 degrees to be displayed on the HMI. So all of us know this one. You open a new project, for example. Let me type a name it boiler. Okay. Insert your station 300 so that you can go to your hardware configuration. Okay. This one is common to all of us. Everybody understand this one. So what we're gonna do, we open the rack. I'll take 300. Ray. Let's choose a CPU to Profibus. Maybe this one. You have to network the. Oh, sorry. CPU to TP. Not the 15. CPU to the pin. Okay, this one. If we network, this one is address to a new network. Maybe you name it maybe boiler network, I don't know. Maybe here you put your auto, maybe my name, because I'm the one writing the program. You can put your comment here. Maybe temperature scaling 0 to 100 degrees, maybe for boiler 1. Okay, so this is our network, but we need to add our analog input, because what we're going to scale is between 0 to 100 degrees. So we'll find our analog input, which is SM300 maybe. This guy is okay. I use this one. What is it doing? You can see here analog input data 15 UV. Okay. So you can see our analog input address start from 256 to 271. So you edit this symbol. Okay. For example, PIW256 symbol, it depends on symbol one. TP 100. I use TP for temperature. And data type I want integer. Then you comment maybe temperature for boiler 1. Okay, the second one will be TP 101. I use integer. Maybe copy this one, comment, paste boiler 2. Same TP 3 103 102, sorry, integer, so on and so forth. Okay, for example, then you okay, so object property, you can see the RT maybe for temperature control. The address is 256 to this, and the input, what we're going to use, what I'm going to measure. What are you measuring? Voltage, that, no. RTD. You want to measure RTD, maybe PT100. Okay, you can use this one. All right, so we comply, save and comply. Here we go, close this one. You open your network. Now the first block you need to open is FC1, for example. FC1, let me say analog scaling. Okay, maybe temperature, boiler 1. Okay, you open this. You have to make another data block so that it can be our referee. You see data block 1, maybe data for boiler 1. Okay, then you open this data block 1. So what we need to do, I need word, I need integral, I need re-explanation, then I need bool. Okay, so if I start, maybe put in my name here, I use a complex variable array. Okay, then so word. Sorry. Okay, so I need complex variable for I'm trying to make a chain of, I don't want to be typing all this long speech, you know. Okay, so this is our data table. I save this one. If I go to data view, you will see a long chain of bool, all the stuff like I just formed a table. Okay, this is what I just formed. Okay, I have a word, integral, bool, read word. So anything I need, I pick from this table. Okay, so you minimize, you open FC1. So what we need to do, we call this one always true. Okay. Okay. Try to make this always true. Let's see, marker 30.1, marker 30.1, marker 30.1. Okay, so we edit this one. 30.1, always true. Open another network, name it always false. Okay. Makata 3.0, Makata 3.0, Makata 3.0. You edit the symbol. Makata 3.0. Always false. Okay, applied. So now we have got this one. So now we're going to do the scaling. The scaling for our level, temperature for boiler 1, for example. The scaling is being already in the Siemens library for our stage. Next videos I will be showing is how to do the scaling in real time. That is, we have to have parameter at low temperature, open this valve, at high temperature, do this, do that, real time with alarms. Okay, but this one is just to display. So you open the library, standard library, converting blocks, TIS, the converting blocks. Open this one, they go down, say scale, just click and paste it here. It will give you this box. So what we're going to do now, this in is the analog peripheral input word from our earlier stage, from the hardware configuration. Yeah, this one from here, the hardware configuration PIW256, that is TP100, the symbol, and it's an integral, and it's a temperature for boiler 1. So we're going to input this peripheral word PIW256 here, PIW256. See, it will give you temperature boiler 1. Okay, so this one is normally open, or normally on, sorry, from this network we just choose. Copy this one here, paste. Okay, now the high limit, some temperature transmitter RTD, some read maybe from minus to maybe 120. So your high limit is where your temperature range stop, maybe. But this one, for this project, we're going to use from 0 to 100 degrees. So our high limit is going to be 100. Okay, and our lowest limit is going to be maybe 0. So if we refer to our data block here, so our highest is going to be this one, which I'm going to change from 0 to 100 degrees. Okay, so this value is the same as 100 degrees. So our high limit is going to be dB1 dBd 68. So dB1 dBd 68, that's our high limits. Then our low limits is going to be 0, this one, that is dB1 dBd 72, dB1.dBd 72. Okay, bipolar is just, you can use input boost any one you want to use, but we'll go to that one later. Input 0.0, for example. And the return value here is after executing the scaling. If I have any error, it's a word. Okay, this one, it's a word. It's a word. If I have any issue with my scaling, it gives me a value, whether minus or an error. So I choose from my data block the return value, which is a word, this one, dB1 dBw0. So my return value is going to be dB1.dBw0 if I have any error. Okay, so then my final output scaling here, After doing all the scaling, if the block scan do all the scaling, if there is no error here at the return value, the return value must be 0, then I will have my scaling at this output, which is a real value too. So I will choose this one. Let's see. Go to real value. So this is high limit, low limit. So our final scale will be this one, 76. So final scale will be db1.dbd76. Okay, bingo. This is just all, it's not too much. Save this guy. Okay. I think I'm having some issue with my simulator. My simulator is a little bit having a problem. Okay, so we insert OB1 here, which is an STL. Okay, call FC1. Okay, our return value, which we know, db1.dbw0. Okay, save, close, save. Then we try to download this guy. I hope it goes. From my simulator, good. My simulator is having some problem. So now we put on our PLC. It's booting. If there's no error, good, there's no error. So open OB1, open FC1. This is what is going to happen. If I go online, I'm expecting 0, 0, everywhere 0, for example. So what I'm going to do, we input the peripheral input word, this one, PIW, copy this one, copy, and you paste here. Then you find slider. The minimum analog value is 0, and the maximum analog value, standard value, is 27648. Okay. By sliding this value is going to change. So we go online. Now you can see we are actually online. Let me change the representation to floating point. You can see my return value here now is 0, my scaling is 0, my highest limit of my temperature is 100, my lowest limit of the temperature is 0. So I scale from 0 to 100, that is from 4 milliamp, I have 0. At 20 milliamp, I have 100 degrees. So if I open the slider, if I slide through, notice what you see here. Now I see 3 degrees. My temperature is rising. 11 degrees. You can see how the values are changing as I'm sliding. Up to 100. Bam. Bingo. So this is how we do basic scaling. But for the HMI, I don't want the temperature to be reading 93.6523 or 90.47 is cumbersome a little bit. So I go offline. So what I need to do, I try to round up this value. So the first thing I need to do, I find a move instruction. Okay, I move this instruction. I copy this instruction. I move it. Okay, then I create MD20, for example, which is a real exponential. Then I round this value, converting block, copy this one, paste here, you round this value, copy this value, paste this value here. Okay, now our final result, we get it from the data block, db1 view, data view 80. Okay, so this will be our final value, db1 dbd 80, db1 dot dbd 80. Sorry, md 30 for example. Sorry. Okay, so I'm just, let's say, moving instructions. Okay. So network, another network, if I move this value, if I move this value, copy this value, then db1 dot dbd 80. So this will be my final result. So I download, yes, then I go online. So you watch this one, 90. You see, now I'm having 90, but initially I have 90.4767. I don't know if you got the point. So what I did, I tried to convert, okay, round this value to 90, not 90, not this one, not 90.4767. It's not proper initially on the display for the HMI. So that is why we do like this 90. Okay, so now I know you grab what I did. We go offline. What we need to do, we open our winncc. I want this value to display on the HMI. Okay, so you open your winncc, winncc flexible. Let's see, final boiler 1 temperature. Okay, now just brief, create one screen like this, maybe one panel, just like this. This is our winncc flexible advanced. Okay, now this is the winncc, this is our display. So what I'm trying to do, that is whatever that is here must be displayed on the screen, so that the operator or whoever is seeing the boiler will know the temperature by visualization on the HMI. So this is what we do. This is the template. The template is where we write maybe the name of the company or whatever you want to do, but we have to do the device settings. For example, that device is too small. I want screen 1. I want to start my screen 1, which I will name as main. I want whatever I display I see on the main. Then this can be maybe boiler 1 if you want to change the name. Boiler 1 can be your name, the author, you that is designing. Maybe I put my name, Solomon.Koroma. Maybe comments, maybe boiler 1 temperature, boiler 1 temperature display, for example. Okay, this inches is too small, so we increase our screen to maybe to multi-panel, maybe 8 inches church screen. Okay, so this is what we have now. So we try to integrate this project with the step 7. We integrate with our project we just did, which is a boiler. I integrate it. I try to marry the step 7 and the winncc together, so that whatever I do on the winncc can be affected to the step 7. It's loading, it takes a while to load. Okay, now if you open step 7, you can see the winncc boiler 1. You see boiler 1 here, this one. I've added the winncc attached to the step 7. So what we need to do now, maybe on the template, we just, for example, on the template we just type maybe boiler 1 temperature display. Okay, so try to a little bit affect it, text a little bit larger, maybe 26. Okay, maybe appearance into blue, or which color you want, any color you want. Okay, blue. So if you open the main screen, okay, graphics, open graphics, symbol factory graphics 256 color, then you choose boiler, open boiler, you display boiler here. There are a variety of boilers. I will take this one. Okay, enlarge. Want to see the display, for example, yeah, so close graphics, input symbol, IO fields. Okay, want to display this value. So now text, open maybe 20. Oh, yeah. So I'll see the actual display. Layout, adjust the value to come down a little bit, and change the appearance maybe to something, no, green, sorry, black, background, something shine, flashy, again, something flashy. Okay, now this is what's going to happen. So if I go to general, input output, no, I want it as a display, so it's going to be an output here. Decimal, yes, but I want it to display like this. So I want to see it in degrees, like 10, 20, 30, all this kind of thing. So what we'll do is like this, click this one, this, sorry, so layout, move this guy a little bit upward like this, then try to create another stuff here. It's a little bit sensitive. Okay, for example, I don't know, just trying to just, so this is the temperature display. So but I want it as an output, and the process tag is here, this one. This is our process tag, db1 dbd80 process tag here. Open this boiler, db for boiler, db80, this the process tag for boiler. Okay, so this is what's going to happen. So I go online, it's going to compile, it's compiling, everything's perfect. Now my temperature now is 0 degrees. So see what is going to happen. I minimize this guy a little bit so that we actually know what we are dealing with here. Minimize this one a little bit since I'm online now. And then this, the project, I minimize it a little bit so that we'll see the actual display. Go online. Okay. So we can see what is happening now. YouTube. So if you watch here, if you can see what I'm doing, here is 6 degree on the program. I'm sliding the I'm sliding my simulator here. Watch this HMI display, watch the scaling, and watch my slider. I move a little bit, 11 degrees, 12, you can see from the HMI is going up. So this is how we do the scaling. So now, for example, the temperature on the boiler is 60 degrees, so you can see clearly 72 degrees. All emanated from the scaling we just did here. It's a basic scaling, very easy to do. So you see, this is the display. So you can do it for all the 3 boilers for your assignment, so 100 degrees. So that's it, YouTube. Thank you for your time, and thank you for watching. Thank you for your support. Okay, at the end of this program, you have my email, everything you want to do. Thank you very much. So this is where I end the project.